Hey everyone, so I am here today to do our experiment number 3. So experiment 3 is an extraction. I have this mixture here of Phensuprin. It is a mixture of acetylsalicylic acid, acetanilide, and sucrose. So here you can see it is fairly uniform. I mixed everything together and then I took it to a mortar pestle to try to make it uniform, mixed it up, and then I measured out some amount here, and that's what we're going to be working with. So again, Phensuprin is a mixture of sucrose, acetanilide, and acetylsalicylic acid. So they all have 3 unique structures, and more importantly, they have unique functional groups. And we're going to take advantage of those differences in functional groups to actually isolate each one of the components. So step 1 is to add our organic solvent right over here. And if you have looked at the Sneeden file as well as the additional lab procedure that I gave to you guys, you will note that there are 2 different solvents used and a couple differences in the amounts. So I will give you guys my notebook so that you can see precisely what I'm doing today. But I have decided to switch from dichloromethane, which is in the original Sneeden file, and today I'm going to be using ethyl acetate. I had one student volunteer to do a bit of research, last spring, and they were kind enough to repeat this extraction experiment, six or so times maybe, to prove that 1, the smaller amounts are going to work, and 2, that the going from dichloromethane to ethyl acetate will also work successfully. So here I am just stirring it. One of the 3 components is going to not dissolve in this case, and what we're going to do is we're going to collect it by a simple gravity filtration. The other 2 are going to dissolve into the ethyl acetate. So the first isolation doesn't actually come from an extraction. It comes just from a straightforward, solubility difference. One of these is not soluble in ethyl acetate and the other 2 are. Of course, things fall apart if you've got, differences. If they all dissolved, we'd have to do other things. But right now, all I'm doing is stirring. And even though they are all 3 solids, they all have a slightly different look about them. And the first component, what I'm looking for here to decide that I am done stirring, that is to decide that all the solid that is going to dissolve has dissolved, is I'm looking for any solid left to be uniform. So here it looks like it's kind of like a clearer granular type solid. The other options were sort of a brownish powder or a white finer powder. So I want to make sure that it looks like everything is the same. And now that that's done, what I want to do is a quick gravity filtration to collect just that solid, and then we're going to move on with the rest of it. So what I have here is just another beaker that I'm going to be collecting our liquid in, just a simple liquid funnel. I'm going to carefully put it in here because I don't want it to spill, and then a filter paper. So this is a fluted filter paper, so if I say fluted, that's what it means. It's been folded up a bunch of times. If you don't have fluted filter paper, you can still use just regular large circle filter paper. You fold it once into a semicircle, fold it again into quarters. It's a bit hard when it's already fluted. And then just open up the little pocket you've created. Personally, I prefer that to the fluted filter paper myself because it fits a little better into these smaller funnels, but that's okay. So I'm actually gonna take advantage of this ring I have set up for the next step and just put that right there. So I have my filter paper in here. I weighed it dry because I'm not certain how easy it's going to be to get the solid out of here, so I'd rather just have this weight in case I need it. I might not need it, but it never hurts to pre-weigh your equipment. And I'm going to wet the filter paper. Not by a lot, because I don't want to dilute the solution I'm working with by too much. But if you recall, there is stuff dissolved in here now, stuff that we care very much about getting back. So if I don't pre-wet this filter paper with the same solvent, what's going to happen is some of this liquid is going to soak into that filter paper and it's going to be gone, right? And that's going to be a loss that we're not really looking for. So now I'm just filtering and I'm going to try to scrape the solid. Try to do it without breathing in ethyl acetate. Some of you may be familiar with ethyl acetate. It's the alternative to acetone that you can use to take fingernail polish off your nails. I prefer acetone because I think ethyl acetate smells like feet. I love it. Okay, got most of it out. There's a little bit on the bottom, but I am not worried about it. So, that aside, what I'm doing is just checking that all the liquid has drained out from here. And what I'm going to do is I'm just going to actually leave the filter paper inside of this funnel. And I'm going to just let it dry. I'm going to let it hang out to the side and begin drying on its own. This would be a great time to write on the funnel or the beaker that it's standing in what that actually is. So solid left from ethyl acetate, step 2 in my notebook, something like that, just so that you come back later and you don't wonder, what is this thing that is in this beaker right here? But now what we have is all of the other 2 components has been dissolved in this liquid here. So there's still 2 components in there plus the solvent, and that doesn't help us out very much. So this is where we're going to begin our actual extraction step. So I have a separatory funnel. It is this kind of pear-ish shaped piece of glassware. You can close it at the bottom with the stopcock, and then you also have a space at the top to close it. You want to use a glass stopper, not the yellow caps. The yellow caps just aren't they're just not as tight. It will leak. This is the closed position. This is the open position. There's a little hole going through the center there. You always want to make sure it's closed, but just on the off chance that it's not, because you forgot, before adding anything to your separatory funnel, you should always put a beaker or some sort of collection vessel underneath it in case you go dump in your solution and it just falls straight to the bottom. You don't want to lose it all. Now we're going to be using this, so I need a separate container here. I also need my glass stopper and then the solutions that we're going to actually be extracting with. Okay. So to take out our first component, well, actually our second component, because our first one is in this funnel over here, we have ethyl acetate, and what I'm going to do is I'm going to extract it with 5% sodium bicarbonate. So sodium bicarbonate, I'm going to call it bicarb as a shorthand, which is baking soda. It's a weak base, so it can deprotonate a stronger type of acid like carboxylic acids or stronger essentially will react with something like sodium bicarbonate. And when that happens, it is going to deprotonate it. That gives it a negative charge on the carboxylic acid. You know, of course, you're going to have your counter ion. So in this case, sodium bicarbonate, sodium. So you're going to make a sodium carboxylate, for instance. And that is going to be water soluble at that point. Sorry, I was thinking about how I actually need this funnel back. So let you dry in the beaker. When we formed a salt, it becomes water soluble, and that means it's going to move from the ethyl acetate layer into the aqueous layer, which again for us is the sodium bicarbonate. From there, we'll have to do a couple extra steps to get it out of here, but at least that will get the 2 components away from each other in the ethyl acetate. So I'd used about 30 milliliters there. I'm going to use about 15 for the first round. We're going to do this twice. So if you remember with extraction theory, it's more efficient to do smaller volumes multiple times than one large volume. Has to do with that extraction coefficient. So you're capped out the certain amount that you can use, not the amount you can use, the amount that can be extracted in a given step. is dependent on that extraction coefficient, and you can't go above that maximum. So doing it multiple times just lets you get more efficient. And what I hope for you to be able to see is the two, I meant to lower this actually, the two layers in the separatory funnel. So they're both clear liquid, so it's not super easy to see, but if you look, there's a line right here. So the bottom is going to be our aqueous layer because it has a density of 1, and the top is our organic layer, which is a density of 0.9. So the less dense one sits on top. If we had used something like dichloromethane, for instance, it would sit on the bottom because its density is about 1.3. Again, water still 1. Now I didn't add just pure water to this. I did 5% sodium bicarbonate solution. But for the purposes of the extraction, we're going to go ahead and presume a density of 1. So if it's a water-based solution, unless it's significantly different, brine, maybe it's saturated sodium chloride, something like that, we're going to go ahead and just assume about 1. I suppose you could calculate it, but 5% sodium bicarbonate is simply 5 grams of sodium bicarbonate plus 95 milliliters of water. I would bet the density is still pretty darn close to 1.0. It's certainly not going to be less, so ethyl acetate is going to be on top. Okay, so you can see I am mixing it. I'm holding onto the stopper here. It is easier for me to do it like this with one finger. Some people with larger hands can actually just palm it. I can't even hold on to it that way. So this is much better for me. I like to do like this, so up and down, not so slow. That's not actually mixing, right? But not so fast that we form an emulsion here. So just kind of a back and forth. And then every so often, we open it to vent it. Make sure you don't point this at your face, at someone else's face, especially when we get to work with people in the lab again. Actually, probably the worst accident I've ever actually witnessed in the lab was somebody was doing everything fine. They're working on their bench. The person next to them was doing extraction, wasn't paying attention, and the whole top just flew off into the lab partner's face. Something like dichloromethane or methylene chloride is a very high vapor density, so it will kind of push back. So if you were working with dichloromethane and you had this on here, you might see it kind of pop up like this. Ethyl acetate is not such a big deal. Okay, so once again, organic layer, ethyl acetate, that's on the top. This is the aqueous layer, our sodium bicarbonate layer. On the bottom, that's what we're collecting, so it's very convenient. All I have to do is let it drain down into this beaker below. This is the beaker I want to use to collect my organic layer. And what you want to do is you want to catch it right as the layer enters the opening here. So, you know, you can slow it down as it gets closer, of course. And your goal is not to let either of the layers mix. Depending on what you're doing next, sometimes it's less of a big deal than others, but it's still a good idea to try not to. So it's my first portion of sodium bicarbonate. Now I'm going to do my second portion. I'm doing about 15 milliliters both times. I started with 30 milliliters of ethyl acetate. So after I mixed it, it looked a little bit cloudy from a little bit of an emulsion and also just the mixing here. It does look a little bit cloudy, but so it's actually a little easier, I think, to see the line between them. Not when I cover it up, I guess. But I'm just going to repeat the process. So there are a few different ways people might say to decide if you're done. Some people just say do this for like a minute or two. I think that can be too long and you risk forming an emulsion, which means you just have to sit there forever and wait for it to loosen, I don't know, disperse, I guess. The other way you can tell is when you go to vent it, if you don't actually hear any gas release anymore, you're not mixing, or there's no change in the mixing anymore, and that's another hint. So, seems done. No more exchange going on. So I'll let that sit. I'll let these separate. So this is, it's not a full emulsion because it's clearing up, but if I had shaken this harder or for longer, all these tiny little bubbles would just form their own little foamy layer there. That's what I'm talking about when I say emulsion. And now that this is ready to go, we are going to drain it again. Again, aqueous layer still on the bottom, organic layer still on the top. This is aqueous layer. I'm going to combine my aqueous layer and my aqueous layer. And what you're going to see here is what happens when I top off. This is a very common mistake I sometimes. And what happens is you can see some came out at first, but now there's no more movement because we've made a vacuum. Some came out, but there's no way for air to get back in unless it chugs up like that, which is just going to mess up the layers and make stuff more difficult. So if you ever see it's really slow or it's not working, just check if you left your cap on. Now, sometimes it gets clogged or something, so there can be other reasons, but okay. So organic layer, aqueous layer. I'm going to put my organic layer back in the beaker it was before. Notice how I'm pouring out the top because I don't want it to mix with the water that drained in through the bottom. So you drain your bottom layer and you pour out your top layer. Again, our whole goal is separation here, separation, method of purification. So, you want to try to avoid mixing if you can help it. So this, ignore the writing, is just our ethyl acetate, which has one component in it. And this is our sodium bicarbonate, also known as our aqueous layer, and it has the salt of our other component in it. So this one's not done yet. This is almost ready. The only thing left in it is the ethyl acetate and a touch of water. So you see it's a bit cloudy, or it's not like a crystal clear solution, it's a little bit murky. That's because even though water and ethyl acetate are not miscible, that's still looking at their bulk properties. It doesn't mean that on a tiny level, at like a ppm level, there isn't some mixing going on. So what we need to do is get rid of that last bit of water before we can then get rid of our ethyl acetate. So, drying agent. When you have removed almost all of the water, all visible water, so I don't have any visible water droplet. Oh God, I'm on fire today. I don't have any visible water droplets that I can pipette out or put back in the separatory funnel. Then use drying agent with your spatula. So what that's going to do is anhydrous sodium sulfate, it would like very much to form a complex with the water. So anhydrous means it's not currently complex with water, but if we add it to something that has water, it is going to be very happy to take that water up with itself, thus sequestering it from the rest of the liquid. So I would usually use like a scoop maybe, but so what you're going to do is you're going to add until you see it stop clumping, because as it's clumping, that means that it's still finding water to, I guess, technically react with. You also note the liquid is quite a bit more clear now. It's not, stop, it's not murky anymore. So I'm going to add a little bit more swirl. And what I'm looking for is when the pieces that I add no longer try to clump up. So not quite there yet. If you had a finer powder, so this is more granular, but a fine powder, you might actually achieve that snow globe effect that people sometimes describe it as. Okay, do a touch more. And so you can see it didn't actually look very wet, right? It's not like we could see water, but the sodium sulfate is finding something to react with. Okay, so now it's hard to see, but there are some loose grains in there. It's not all in this one big clump. So I'm going to let that sit for a moment. What we're going to do after this is either filter or decant into a round bottom flask, and this will go onto a rotovap, short for rotary evaporator. I never actually say that out loud, so just rotovap from me. That's basically a giant vacuum distillation, and it is going to evaporate off the solvent and leave whatever is not solvent, whatever is not a liquid at this pressure and temperature range, behind in the flask. And hopefully that is our pure compound, whichever one we expect to be in here. Okay, so we'll come around to that one in just a moment. Even though we can see that this seems done and it looks nice and clear, technically you should let it sit for a few minutes just to make sure that all that water is kind of soaked up, I suppose. So I'm going to let that sit for a moment, and we're going to come back to this one right here. So remember, this was our sodium bicarbonate layer, and it has the salt of something in it, so the salt of one of our 3 components. And what we need to do is get it back first as neutral, so we don't want the salt, we want the neutral version, and then separate it out from the water. Fortunately, the way that acid-base extraction ends up working most of the time, and what makes it such an efficient purification method is when we acidify this organic layer, so it's a base, it's basic right now because it's sodium bicarbonate, we're going to add acid until it becomes about a pH of 2. That will reprotonate that carboxylate to give us back our neutral carboxylic acid, and it will no longer be water soluble. The only reason it's in here in the first place is because we deprotonated it. So if we give that proton back, it will have no reason to stay in the water. It will come out as a solid, and we can just vacuum filter it, and we will have our next component. Okay. So I went and I just grabbed the 6 molar HCl. I prepared it earlier. You might still be able to see some of the bubbles because it got pretty hot when I mixed it. So I just took our stock concentrated HCl, I diluted it down to 6 molar, excuse me. And that's what I'm going to use to acidify our aqueous layer. So I just want to check what the pH is currently. So I got a strip of pH paper. I do not need this whole strip to just check one pH. I'm going to tear off just a wee little bit, right? So like this much, just enough that I can hold on to it. I'm actually just going to go and put it on the tip of my finger here, and I'm going to take a pipette. I'm going to just go pick up a drop. I'm going to add it to the paper, and I'm going to see what it is. So I don't know how easy it is to see. It's kind of a light green, kind of a light limey sort of green, which I'm fairly certain is a pH of 8. I don't have the scale on me, but I'm pretty sure that's what it is. So what we need to do is start adding HCl carefully until we get to a pH of 2. I do know what that looks like. Because I know that it is going to get hot during the addition, I'm going to just keep the ice right here in case I need it real quick. So 6 molar HCl, it's not fully concentrated, it's pretty concentrated though. Stock HCl is about 12 molar, so I still want to be careful, it's still pretty corrosive. I'm just going to take a pipette and I'm just going to add that amount. So you can see, you can hear it bubbling. You probably can't hear it bubbling, but you can see it. So that is the reaction of HCl and sodium bicarbonate, as well as our carboxylate salt. So we need to make sure we add to a pH of 2, because not only are we trying to neutralize our compound, we need to neutralize all of the sodium bicarbonate that's in there too. So see it's bubbling. You can also see some solid is forming as well. If you were listening to it, it would sound like if you took like a bottle of soda and you undid the top and you poured it out, you hear all the fizzing, same kind of thing. No one's paying me, so I'm not going to drop any product placements here. But yeah, so there's a combination of foam just from the reaction, as well as just solid forming. So the solid is not water soluble. Try if I can do this successfully. I cannot do this successfully. I don't want to move this. Anyways, so it's kind of sitting on top of the bubbles there. Now's a good moment. I'll go ahead and check the pH. Check a different finger. New pipette. So I don't want to use the one that I've been using to grab acid. I don't want to use the one that I started with, so I just grabbed a new pipette. 1 drop. That's a nice pink color. Maybe about a 3. I think I'm accustomed to a slightly stronger pink. So I'm going to try another bit of acid here. So you also see it's still reacting a little bit as well. Not too hot though. Try one more. Okay, so that one I didn't really see much of a change. So still always swirl. Anytime you're doing additions, especially for neutralization purposes, make sure you give it a good swirl before you test it. In an ideal world, you would also be swirling as you add, because again, creates a lot of heat when you add acid to something. Okay, so it's a good strong pink color. It's hard to see, but okay. Okay, so no real change there. Seems like it is done. So what I'm going to go ahead and do is just let it sit on ice. So I'm going to let it sit on ice. You can see some of the solid floating on top. So even though it's neutralized, again, if we lower the temperature, it's going to cause it to precipitate out even more. We're not recrystallizing. This is actual just precipitation. We're crashing it out of solution. We are trusting that there are no other things that would be solid. So it would just be water, some sodium bicarbonate, HCl, byproducts of that reaction. So some sodium chloride is going to be in there, and water. And we want to just maximize as much solid as possible to come out. So we let that sit on ice. While I let that sit on ice, I'm going to go ahead and set up the rotovap. Well, actually, before I set up the rotovap, I'm going to show you guys me putting it in the round bottom because I do want to show you guys. So round bottom, I have 50 milliliter round bottom here. I'm going to weigh it first because it is not going to be easy to pull the solid out. It's, it's a sphere. It's not easy to scrape the solid out. So you want to make sure that you get the weight, the mass of it. Okay, so I'm going to write that down in my notebook, and then what I'm going to do is I'm going to go ahead and I'm going to clamp it because I don't want to get anything on my hands. So if it fit in here, I would just put it in here, but it does not. So I'm going to just take one of these little clamps here to hold it. You could use a funnel, do like a full gravity filtration, but I think I'm just going to go ahead and decant. So it's been sitting over here. It looks nice and clear. And what I'm going to do is so decanting is simply pouring, leaving a solid behind. So I'm just going to carefully pour, and I'm going to make sure that the solid stays left behind. Because I don't want that messing up my mass or my melting point later on. So if you were uncertain about this, if you thought there was a bunch that would come out with it, for instance, magnesium sulfate or a very fine powder, I would probably not decant. I would probably do a full gravity filtration. There you go. So that leaves a solid behind. Doesn't look like I left any real liquid behind. And just to confirm, okay, we don't see any solid in here. Why not? Knock it over. Okay, so this I'm going to take to the rotovap and remove the alcohol state. Hey guys, so okay, hopefully you can just cut that out. Okay, hey guys, so I have our ethyl acetate with our compound right here, and I'm just going to put it on our rotovap. So it's just a very large vacuum distillator, basically. So first thing I'm going to do is I'm just going to clip it onto the end here. So I want to use a cat clip. That way it's not going anywhere. And then what I need to do is make sure there's water running in the condenser. And there is. I can hear it leaking behind me. I've got a hot water bath running right here. And then I'm going to start the arm spinning. Oh no. What that does is that just makes sure that, sorry, a little bit of something got in there. I'm gonna deal with that. Okay. So I just turn this on. That just helps increase the surface area and keeps it from bumping. And then I'm gonna turn the pump on and close the vacuum. So now the vacuum's on. That's going to decrease the pressure in the system. And what that means is it is going to start evaporating. You know, I won't have to heat all the way up to like 78-ish degrees or whatever it is. Okay, sorry. Because these are all connected in a series, I had to go make sure that the other one was also closed so that it would work. But it is, so you can maybe see some bubbles. Maybe not, I don't know. But that means that's evaporating. So it's going to evaporate. It's going to leave a solid behind in here. And then we will have our compound. We'll have the one from the aqueous layer, this is the one from the organic layer, and then the one from the very beginning. So I will do the masses, the melting points tomorrow, and we will go from there. Okay, so while the Rotavap is removing the ethyl acetate from our other sample, I am going to vacuum filter to collect our solid from the aqueous layer. So you can see a fair bit of solid has formed, and I'm going to collect that with vacuum filtration. So it's a bit too fine for gravity filtration. It's also water, so we would just be like sitting for just like forever. So we're going to do vacuum filtration. It's much more efficient, and it will also help dry the solid. So the first thing I'm doing is simply clamping this filter flask in a position that you can see to a ring stand. So it's important to do that because what we're going to do is add the vacuum hose. That's fine. There we go. To right here. And it's not like a lightweight hose. It's a pretty heavy hose because we're connecting it to a vacuum. So I want to make sure it is clamped before I start messing with that. So I don't break anything, so I don't lose my sample. I have set everything up before on top and then gone to do this and just like flung, like literally like slapped the whole thing away. So I'm going to start with this. And you also do it so that like when you walk away, the hose, because like you could do the hose first, might be easier in fact. And then once it's on there, then clamp it. Totally fine too. Because the whole point is you just don't want this to go away. Now the Beekner funnel is the funnel with the flat bottom. So it looks like this. And we want it to sit in here. It is going to collect our solid. But this is not airtight, and we're doing a vacuum filtration. So what we're going to do is put our Thomas filter adapter right here. Then we put the Beekner funnel in. That's going to create the seal that holds everything in place. And then there is a little round filter paper. You can buy them. So the Beekner funnels come in standard sizes. So the filter paper also comes in standard sizes. You can buy them pre-measured out. We could do it by hand. And then what we want to do is we want to check that the pump is working before we start pouring anything in here. Because once we pour in here, it's a lot more work to go switch to a different setup. So I'm going to turn the pump on. And then what I'm going to do is I'm going to check that it feels like I have a nice strong pull from the vacuum. So you can hear the change perhaps. But more importantly, you can feel it pretty well. So you can see like the outline where it was. Now the final thing that we need to do is seat the filter paper, and what that means is we want to add a little bit of the solvent that we are removing with the filtration. So in this case, some water. So Just use some melted ice. And what that does is it makes sure that the filter paper is nice and flush with the bottom there so that when I add this, liquid doesn't seep around the filter paper. And then I'm just going to start filtering. So I'm a big fan of you swirl first and then you go straight to pouring. It's basically the opposite of decanting. You want to try to bring as much solid with you, with the liquid, as you can. And you don't want to overflow, so make sure you pause. There's still some liquid in here, so I'm going to add a bit of water and try to scrape it off the sides with my spatula, or even just the pipette. Seems to be working. I don't really worry that it's going to dissolve in the water in this case. Back when we did recrystallizations, you could very well accidentally redissolve the solid you just recrystallized, so you'd want to be careful how much solid you add. In this case, I don't worry that it is going to dissolve. So it was only water soluble when it was deprotonated. Okay. So then what I like to do is I like to let the vacuum run for a few minutes. First thing you can see, there is no solid in here, it's just clear liquid. All the solids in here, so we didn't lose any in this step. It's pretty good. And I like to let it go here because that helps it dry. I'm not going to take the melting point or the masses today. I'm going to come back tomorrow, weather pending. And by then it should be dry, but because water is pretty difficult, I like to let it sit over the Airstream for a couple minutes anyways. And what I will do as it's drying is called fluffing it. So I know you won't be able to see it, but you simply take your spatula, you just kind of stir gently so you don't want to dig up the filter paper. Stir the solid, kind of increase the surface area there, remove, break up any clumps that you have. Give it a better chance to dry. A lot of times, it's not 100% of the time, but a lot of times you can get a feel for if a solid is dry or not if it is sticky. So if it releases from the glassware or something very easily, just kind of crumbles apart, that's typically a sign that it is dry. If it wants to stick to itself or the sides of something, it's probably still wet. Now, because I'm going to let this dry overnight, I don't need to let this keep running too much longer. So before I turn the vacuum off, I must release the vacuum. And you should always do it by pulling the hose off. So I've done that. Now this is free. Now I can hear again. And what I'm going to do is I'm going to let this dry in the Buchner funnel overnight. And then I will scrape it out onto something later to weigh it. You'll notice, you may or may not have noticed, I did not weigh the Buchner funnel and I did not weigh this little circle of filter paper. I don't typically. I think that with the flattened bottom and the volume that we're dealing with, the amount of solid that we are dealing with, it's easier to just scrape it off, onto like a watch glass or something. But you may have chosen to weigh those if you were in the lab. Totally valid way to go. Okay, so I want to go grab the solid that has been on the rotovap, and then we will just take a look at what they all three look like, and tomorrow I will do the melting points and the masses, and that will be it. Hey everyone, so I have been spinning the sample on the rotovap, and now we are ready to take it off. So if you're ever using a rotovap, if you put it on, it's very easy. You just do it in reverse order. But again, the same rules apply as when we're dealing with the vacuum filtration apparatus, which I know you didn't actually see for recrystallization, but you're going to see it today. Disconnect the vacuum before you turn anything off. So the vacuum's still there, so I'm just going to open the valve here. If you were here, you would hear it hissing. it'll kind of peter out a little bit. It'll hit a constant tone, or you could just feel for it as well. And then if it's done, you go ahead and stop. So you can see we have solid now. Remove it. Well, I've opened this, so I'm going to turn the pump off first. If you try to take it off while the vacuum's still running, what can happen is some of the stuff can get pulled back up in it, which is kind of what you see here, if you can see that far. So here is our sample. So we see a bunch of white powder around the sides. This is why we weighed this, because it's not going to be easy to scrape this out very efficiently. So this was what was in our organic layer, and yeah, so move on from there. Okay, so we are just about done with our extraction experiment. I'm done for today at least, and what will happen tomorrow is I'm going to take the mass of each one of our solids. So I just want to go in order here. I have solid in this fluted filter paper that I will be weighing. That was the solid that did not dissolve in ethyl acetate, the first one I collected. Then this is the solid that is in the round bottom that I put on the Rotovap. This was what was left in the organic layer after our extractions. So I'll let that sit here. And then what I have in the Buchner funnel is the solid that was in the aqueous layer. So this solid I had neutralized with the HCl, a solid form. I did vacuum filtration to collect it. So we've got 3 solids. So that means we're going to see 3 masses and 3 melting points. And you're going to be able to use the masses to calculate the percent compositions, or percent recovery and percent composition of the initial mixture. And you should also, you should know what each one of these solids are. So you've got the procedure and you've got the background for acid-base extraction, so you can determine what each of these were. Remember, our 3 options were sucrose, acetanilide, and acetylsalicylic acid. So each one of these should be 1, and the melting point is going to tell us if it is pure or not. So I will present that data to you in a series of pictures and numbers. I'm not going to film myself doing the melting points or weighing them out tomorrow. So yeah, this was our acid-base extraction experiment. Thank you guys.